Welcome everyone, and thank you for attending our Make Innovation Pay webinar today. The agenda is as follows. We'll start with introduction and acknowledgements about Invent. So we'll talk about who we are, what it is that we do, and how we help the construction industry. An introduction to the scientific research and experimental development, also known as SR&ED. The opportunity for Albertan construction, the SR&ED qualifying expenditure, the Construction Innovation Fund, and then we'll leave some time for a Q&A after the webinar. So a little bit of history about myself. My name is Sheldon West. I'm the Vice President of Business Development for Invent in Canada. I spent the last 12 years working in the building materials and construction industry from a manufacturer's point of view. I've worked for companies such as SR&ED, Rockwool, and ASSA ABLOY. Really cutting my teeth around roofing, both residential, commercial, insulation, and building envelope. Outside of that, I do spend some time speaking with students about the importance of trades, construction, and innovation. And I show them ways to kind of navigate that industry and networking and the like. I'm passionate about innovation and sustainability in construction. I've taken various courses, attended various webinars over the last 12 years, just really getting good knowledge about the industry and how it's moving forward from a sustainability and innovation point of view.
Hi, good morning, everyone. I'm Ben Pritchard. I'm a Senior Vice President for Invent. My background is in commercial and project management, predominantly within the nuclear decommissioning sector and within the restoration of historical buildings and the likes. So my role has always historically been around sort of starting a project right and seeing how to drive better value in there. And I've been heavily involved with a number of initiatives for a number of years on improving the industry, and have been doing SR&ED claims in Canada and similarly R&D claims in the UK for the last 5 years or so.
Great, thanks. So Invent is a management consultant. What we do is returns and project outcomes to the enhancement of innovation, productivity, collaboration. We are a team of business-minded individuals, but we also have a background in construction in various verticals. And we aim to help the Canadian construction business save millions in tax and free up capital to innovate and overcome technical challenges. So unlike other SR&ED consultants you might see in the industry, we start with the technical know-how, and then we apply our tax expertise, ensuring we identify every cent of qualifying expenditure. So where are we located? Our head office is in the London, UK, and we also operate in Ireland and Canada. Our Canadian office is located in Toronto, and we have a registered business in British Columbia. So we can service our clients coast to coast in Canada and as well as over 15 countries worldwide. As Ken mentioned, we also are a partner with the Canadian Construction Association. I believe the tail end of 2019, we became their SR&ED tax credit partner. And our aim is to incentivize Canadian construction businesses of all sizes and types to invest in innovation by offering a tax relief on the challenges that they overcome with innovative technical and engineering solutions. This partnership has been strengthened by the introduction of the Construction Innovation Fund, which drastically reduces the time from making a claim to receiving the tax credit. And here's a quote from Mary Van Buren. She's the president of the CCA. The Canadian Construction Association and Specialist Construction Management Consultancy Invent have partnered to raise awareness and educate businesses in the sector about tax relief claim.
So this is where I take over for a little bit, and I'll sort of quickly run through sort of an introduction to SR&ED how that's applicable to the construction industry, and run you through a few case studies that we have across Canada to try and sort of bring it to life a little bit for you. So SR&ED tax credits have been around since 1984 and are designed to encourage innovation by allowing businesses to reclaim some of the money they've spent on sort of innovation, creating new products, all sorts of things like that. Canada, we're actually the first country to introduce this type of incentive program, and it's now sort of in various shapes and forms, has been copied in, I think it's around 35 to 40 countries around the world. What we see, what we've seen in most countries that we operate in, that actually claims by construction, although construction is a fairly sort of large contributor to the economy, worth around 10% of GDP in Canada, the shares of SR&ED claims are very small in comparison. Around 1%, if not slightly less, of the total pie is given out to construction companies in Canada. And there's a number of reasons for that we find. Predominantly the one that SR&ED is poorly understood by construction, and innovation in construction is poorly understood by sort of accountants and people who have sort of been in the sort of the SR&ED industry for a number of years, who see it very much as a sort of a technology focused area. But according to the CRA, any project that seeks to extend overall knowledge or capability, create a process or service that extends knowledge or capability, uses technology to replicate and improve what you're doing, makes appreciable improvements to the outcome. These are things that the CRA recognise as sort of being innovative, as being sort of allowable and applicable within the SR&ED programme, and things that you may not realise, but probably on a construction site on a day-to-day basis, most of you will in some way, shape or form have to do to be able to build what you're trying to build. Qualifying expenditure is quite comprehensive. Direct staff, subcontractors, indirect staff, overheads, materials can all potentially be looked at and form part of the claim. The important thing is understanding how they can be attributed to the activities that you do that are part of the SR&ED. There are some rules around the subcontractors, that can make it allowable or not allowable. So where the subcontractor originates from, what the work is that they're doing, what your contractual relationships and things like that are. These are all things that we are well versed in looking at. I've been doing these claims for a number of years. However, our sort of lead SR&ED consultant in Canada, Couture, she's been doing SR&ED claims for over 15 years, and all of that within the construction industry. You won't find, or we're yet to find anyone who has that sort of breadth of experience that she has. So as we've sort of already touched upon, the total value of claims by construction companies is quite low compared to the GDP of the industry in Canada. And for Alberta specifically, the region and the whole, around $2.1 million of claims were made the last time the CRAs released the statistics. However, when you consider the size and the breadth of the industry in Alberta, we reckon that should be at least tenfold more, if not more, considering some of the complex, heavy industry that Alberta is well known for. So getting into the meat of it, as it were, and how that applies to construction. But as we are an industry that is well known for overcoming problems, but not necessarily thinking of it as being innovative in how we overcome those problems. But if you think of a science experiment and you try and think of the various stages of a construction project, your design intent, your hypothesis, your experiment is sort of the development of that design, trying to develop a final solution that can overcome a number of technical and scientific uncertainties, number of engineering uncertainties, uncertainties in how systems will work together, uncertainties in how technology could or couldn't be developed. And as an industry through Canada and around the world, with a real strong focus at the moment on creating more sustainable buildings. There's a real strive across construction to create better buildings, to create buildings that create less carbon, that require less carbon to be built, that are more sustainable, that use technology in a better way. But there is no benchmark for a lot of what we do. So how the requirement to develop a slightly new way, a new understanding of how that technology, that system works, it is required in a number of projects. And not just on the sort of the large scale, but even in smaller scales. You might see what might be viewed as a fairly sort of simple standard process in the oil and gas industry. When you sort of look to try and apply that in construction, if you have to sort of get a lot of approval from the province or sort of any other local government type establishments, you're using technology in a way that it hasn't been used before. You're sort of looking to prove that there's a better way of doing things by learning from elsewhere and sort of requiring a bit of sort of applied research and the likes to achieve that. So the type of things that could qualify, developing new materials and techniques to suit design aspirations, the construction of buildings, the external envelope, how can that improve heat loss, heat transfer, how can it, if you're going higher, how can it withstand certain sort of wind loadings and things like that. The use of timber is sort of becoming more and more prevalent across the world. But the higher you grow, the higher it goes, the less benchmarks you have on understanding what does that mean, what is the loading requirements on that, how does that integrate with your slab in infrastructure, an understanding of when you use new materials, you're using geopolymer, concrete as an example, there's not a lot of understanding of what that means and how that works, what application is there of that. Overcoming complex ground conditions. There's, again, every time you go underground, there's limited knowledge available to you on what that means in terms of how construction can be applied. So as you research that, as you understand what that means to your construction methodologies, your engineering solutions, that design thinking, that engineering time has potential to be considered SR&ED. Use of technology for the first time. Ken, before everyone joined this conversation, we were talking about a few really interesting bits of technologies that are being looked at in the province from Israel. How can that be used in country? One of the examples, one of the case studies we look at is a wastewater treatment plant where some of the treatment technology had never been used in Canada before, had only been utilised in the States once or twice. So again, the knowledge and the understanding of what that means, how that integrates with local infrastructure, what that means in terms of energy requirements, what that means in how the waste that goes in it, how that will be treated, all of these things. There's a lot of engineering that goes into some of these things. But even on a more sort of, again, sort of a smaller scale, over the past 12 months with COVID, we've really had to sort of up our game with technology and up our game in how we utilize technology to build things, but also how we utilize technology on sites. And these are technologies that might be used elsewhere, but in terms of construction, understanding where people are, how to monitor how close people are, how do we create contactless buildings? How do we create experience for people that you reduce the amount of touch points that we have. This embedment of new technologies within, of standardized approaches to construction is improving the outcome for all, and that can be considered potentially for SR&ED. So I think I've covered most of them. The key thing in all of this is really understanding the engineering input, design, thought and consideration that are put into these solutions. How you overcome these difficulties and issues, or just sort of very aspirational outcomes in what you build and why you build it. So in terms of case studies, so an engineering consultancy specializing in tunnels. So we were able to demonstrate that through solving complex geotechnical issues, the retaining systems that they were developing were very bespoke and unique, because there was no sort of benchmark and available data for tunneling in and around Ontario at this depth, at this sort of length, utilizing sort of some of the tunneling solutions that they wanted to. So the analysis and optimization of the structural designs, minimizing the amount of concrete but ensuring that it's safe. What impact does that have? How can you minimize the disruption above ground while you're constructing? All of these things had to be well considered, and understanding what this means in terms of not just construction today, but also maintenance over the next sort of 50 years. Is there a different sort of application of mix, utilizing different additives and things like that that will reduce maintenance, strengthen concrete, but also be usable when you sort of get it into the tunnel. The wastewater treatment plant technology, so I've sort of mentioned this before, the core technology was untested in Canada, and implementation was further complicated because the rest of the infrastructure, so the sewage plant and things like that, hadn't been built yet. So you've got a brand new piece of technology that you're trying to design around, whilst also sort of assuming best case, worst case scenario with some of the sort of the flow requirements, the energy requirements and things like that. But there was also sort of a change in regulations around earthquakes and things like that that had to be considered. Again, not a lot of available data, and there are also restrictions in terms of the height of the building. So where ideally the building would have been about 25 meters high to give real sort of the optimal room for maintenance and for all the other systems required, it had to be sort of down at 20 meters, and you couldn't sort of go wider to overcome that. So what did that mean in terms of getting the technology to work, and how did you sort of build a solution around that? This wouldn't have been able to be built a few years ago, before digital technologies, before BIM and other sort of related design technologies could allow us to build to tolerances that we couldn't before. One of our smaller clients is a subcontractor, especially a subcontractor that have developed a proprietary precast concrete parking structure. So nothing particularly fancy and sexy in many ways. However, it's all about what they're trying to do to improve their proprietary system, trying to demonstrate that again, using different concrete mixes, using ultra high density concrete. Does that mean that we can do away with waterproof membrane? What does that mean for costs? So with this one, we were able to benchmark lots of how much quicker is it compared to traditional methodologies? How much cheaper is it compared to traditional methodologies? How much safer to an extent it is to traditional methodologies? So we were able to sort of really sort of demonstrate that this slightly different methodology, the system that they had developed, was greatly a great improvement in the outcome compared to traditional concrete, traditional construction methodologies. But also not just sort of some of the things that people do out on site, but also more internally within the office. So we helped a Waterloo-based app developer who identified that there was a bit of a gap in the market they saw. So they had a small construction company, and they felt that a lot of the construction management technologies available to them were not applicable to a company of their size. So they looked to develop their own app, very much targeted at micro and small contractors. And we sort of helped them identify which part of that was more off the shelf coding, and which part of that was more really developing something new, something sort of unique, and required that sort of little bit extra that turns sort of innovation into something that is SR&ED applicable.